Prep 7, Correlation. In this video, you will learn the definition of correlation, as well as the difference between linear and curvilinear relationships. You will also learn how to compute a Pearson's correlation analysis on Excel, and you will learn how to interpret the results of that analysis. Finally, you will learn about the limitations of drawing a causal relationship based on a correlational analysis. A correlation is a relationship or association between two variables. Two variables are correlated or related when a change in one variable is associated with a change in the second variable. And what I mean by change is an increase or a decrease. So in other words, a relationship is when an increase in one variable is associated with either an increase or decrease in the second variable. For example, there's a relationship between hours spent studying and test performance. The more people tend to study, the less incorrect answers they receive on the exam. The price of a home and days on the market are also correlated. Increases in the price of a home tend to be related with more time on the market. There can be a linear or curvilinear relationship between two variables, and you can determine which one you have by creating a scatter plot. If the dots on your scatter plot roughly form a straight line, or in other words, you can draw a straight line through the middle of your dots, you have a linear relationship. There are two types of linear relationships. If your dots formed a curved line, then you have a curvilinear relationship between the variables. There are many different types of curvilinear relationships, as there's many different ways that a line can curve. In this class, we are going to focus on linear relationships, and you are going to learn how to conduct a Pearson's correlation analysis on Excel. Pearson's correlation is the most common type of correlational analysis. It's used to detect a linear relationship between two quantitative variables. It's only appropriate to conduct this analysis if you're working with quantitative variables. The end result of an analysis is a number. This number is referred to as Pearson's R, or a correlation coefficient. This number can range from -1 to +1. This Pearson's R, or correlation coefficient, will describe two aspects of the relationship. First of all, the sign of the coefficient will indicate the type of relationship you have. In addition, the numerical value will indicate the strength of the relationship. First, I'll go into more detail about the type of relationship. If your coefficient, or your Pearson's R, is negative, that means you have a negative relationship. This means as one variable increases, the second variable tends to decrease. An example of a negative relationship is the relationship between product availability and consumer interest. So typically, decreases in the availability of a product is associated with increases in consumer interest. If your coefficient, or Pearson's R, is positive, that means you have a positive relationship. A positive relationship is when increases in one variable tend to be associated with increases in the second variable. I could also reword this to say, as one variable decreases, the second variable tends to decrease as well. One example of a positive relationship is the relationship between price of a product and perceived quality of a product. So typically, increases in the price are associated with increases in perceived quality. Likewise, lower priced items tend to be perceived as being lower quality. The closer the Pearson's R, or the correlation coefficient, is to 0, indicates there's not a linear relationship between the variables. For example, shoe size is not associated with IQ, so increases in shoe size is not associated with increases or decreases in IQ. In summary, the sign of the Pearson's R indicates whether we have a positive, negative, or no relationship. On the other hand, the numerical value of Pearson's R will indicate the strength of the relationship, or how strongly associated the two variables are to each other. If your Pearson's R ranges from 0 to 0.19, you have no relationship to, at the upper end of the range, a very weak relationship. Any coefficient between 0.2 and 0.39 is considered to be weak. 0.4 to 0.59 would be considered moderate. 0.6 to 0.79 is strong, and 0.8 to 1 is very strong. And again, the same scale would apply for negative relationships. When it comes to categorizing the strength of your coefficient, or your Pearson's R, Ignore the sign, just look at the number, and that will indicate how strong the relationship is. In this example, you can see that there's 6 coefficients, and you need to rank order them from the strongest to the weakest. So which one is the strongest relationship? A coefficient of negative 0.84 would be the strongest. Again, when you're classifying the strength, ignore the sign and just look at the numerical value. 0.8 would be the second strongest, negative 0.72, third, 0.63 would be 4, 0.3 would be 5, and the weakest coefficient would be negative 0.17. If you're wondering what the strength of a relationship is, it's referring to how closely associated the two variables are to each other. When you have a very strong relationship, the dots on the scatter plot are forming a nice, neat, straight line. The weaker the relationship is, the dots are still forming a straight line, but they're a little bit more spread out. It's always important to discuss correlation and causation. Correlation does not imply causation. You could have a very strong relationship. You could have a 0.95 coefficient between two variables, and that does not necessarily mean that one variable is causing the other. It could be that there's a causal relationship, but it could be that there's not. And that's because with correlational analyses, there's always the possibility of a third variable. So a third variable is responsible for the relationship between the two variables. So for example, ice cream sales and violence have a strong positive correlation. So what they find is that increases in ice cream sales are associated with increases in violent crime. But we would never conclude that eating ice cream causes people to commit violent crimes. And that's because there's a third variable that's responsible for the relationship between these two variables, and that would be heat. So heat tends to increase ice cream sales. People like to eat ice cream when it's warm outside. And heat has also been known to increase human aggression. So violent crimes are more often committed during the warmer months. Now I can show you how to conduct a Pearson's correlation on Excel. If you go to your prep file under the correlation tab, you will see that there's data on the number of sales calls each salesperson has made, as well as the number of copiers that they've sold. What we're going to do is we are going to conduct a Pearson's correlation to determine if there's a relationship between these two variables. There's 2 ways in Excel to accomplish this. The first way is to write a function. So the correlation function is CORREL. And what you do is first you highlight the data for the first variable, do not include the heading, and then comma, and then highlight the data for the second variable. Again, do not include the heading. If you close the parentheses and enter, you can see this is the Pearson's R, or our correlation coefficient. It's 0.76 if we round to 2 decimal places. We can also compute a correlational analysis by using the Data Analysis Toolpak. If you go to your Data tab, you can access the Data Analysis Toolpak, select Correlation, and hit OK. For my input range, I am going to select all the data for my 2 variables. I'm going to select labels in the first row because when I highlighted my data, I included my labels. I strongly recommend that when you highlight your data for the input range, include your headings, and then make sure that you check the box. For the output range, I'm going to select output range, and this is very important. For the assignments, there will also always be a designated cell. It'll say place output here. So always make sure that you put your output in the correct spot. If you put it in the incorrect spot, if you put it somewhere else, you'll get it marked wrong. So make sure that you always are very careful where you place your output. You will get this warning message, just hit OK. And this is the output from the correlational analysis. This is called a correlation matrix. And this right here is our correlation coefficient. And obviously it's going to be the same as the function. It's 0.76. Now what we can do is we can interpret our Pearson's R. we can draw a conclusion about it. So what type of relationship is there between the number of sales calls and copiers sold? If you remember, the type of relationship can be determined by the sign of the coefficient. So if the coefficient's positive, you have a positive relationship. If it's negative, you have a negative relationship. And if it's very close to 0, that means you have no relationship. Our coefficient is positive, so that means we have a positive relationship. So I'm going to answer this question in the answer sheet. I'm going to put A because we have a positive relationship. We want to explain what that means. So what does a positive relationship mean? If you remember, a positive relationship is when you have increases in one variable associated with increases in the second variable, or likewise decreases in one variable is associated with decreases in the second variable. So that means that A and C would be the correct answer. So increases in the number of sales calls is associated with increases in the number of copiers sold. C means the same thing, it's just phrasing it in a different way. So E is the correct answer. Now we want to categorize the strength of the relationship. If you remember, the strength of the relationship is indicated by the numerical value. If we return to our chart, we can see that we have a strong relationship. So returning to my answer key for question number 3, I can put D, and that's because our relationship is strong. The last thing we want to do is create a scatter plot that demonstrates the relationship between sales calls and copiers sold. I'm going to highlight my data on the 2 variables. I'm going to go to Insert, and then I'm going to insert a scatter plot. Make sure to put the scatter plot in the designated area. And then you're going to want to use proper formatting. In the next video, I'll discuss regression analyses.